In this video, we are going to find positive integers n such that 8 to the power n plus n all divided by 2 to the power n plus n is an integer. Before we move on, don't forget to give a like, subscribe to our channel, and turn on post notifications. To simplify the question, we notice that there is a very clear multiple of 2 to the power n plus n, which is, of course, very close to 8 to the power n plus n, and that's 8 to the power n plus n cubed, because on one hand, 8 to the power n is the cube of 2 to the power n, and n cubed is obviously the cube of n. So it's by the sum of cubes identity, this can be factorized as 2 to the power n plus n all multiplied by 4 to the power n minus n times 2 to the power n plus n squared. And so that's a multiple. And of course, there's a common term with the given numerator. That means, therefore, the given fraction minus the multiple that we have considered divided by 2 to the power n plus n is still an integer. And simplifying, we can say that n cubed minus n all divided by 2 to the power n plus n. Notice that I'm not exactly taking the difference, but I multiplied that by minus 1, but still is an integer. From this, we must have one of the following. Either the numerator is at least equal to the denominator. We notice that both the top and the bottom must be positive or 0, at least not in non-negative, because n is given to be a positive integer. And then the second case would be the numerator equal to 0. Then it will have to be smaller than the only case that it is smaller than the denominator, but the fraction is still an integer. The second case is easy because that only implies n equals to 0, 1, or minus 1. We can quickly remove 0 and minus 1. So 1 is a valid solution. Now, back to the first case, that means we must have n cubed minus 2n being larger than or equal to 2 to the power n. But we can take a look at these two terms. Intuitively, whenever n increases by 1, for n cubed, it will become n plus 1 all cubed. The ratio of increase would be n plus 1 all divided by n all cubed, versus for the power of 2, when n increases by 1, it will be doubled from 2 to the power of n to 2 to the power n plus 1. So it multiplies by a factor of 2. And we'll always have some n that starting from that number, when n goes larger, n plus 1 all divided by n all cubed would be less than 2. And that will start to happen when n is at least 10. Notice that 2 to the power of n by that time will be larger than n cubed, and in particular, even larger than n cubed minus 2n. So that inequality above will not hold. There are many ways to prove this, just to justify it rigorously. You can either do induction, or you can take a look at, we can treat both sides as functions and consider the rate of increase. But intuitively, we know that it's going to work. So, therefore, no solution when n is at least 10. So there are only a few possibilities left, which are n between 2 and 9. So we can test them one by one. When n equals 2, the fraction would be n cubed minus n, so 2 cubed minus 2, all divided by 2 to the power n plus n, so it's 2 squared plus 2, which is 1, I take. When n equals 3, that will be 3 cubed minus 3. Let me highlight where n should go. So it's 3 cubed minus 3, all divided by 2 cubed plus 3, and that's 24 over 11, not valid. When n equals 4, 4 cubed minus 4 over 2 to the power 4 plus 4, so that's 3 is a take. When n equals 5, 5 cubed minus 5 all divided by 2 to the power 5 plus 5, we'll have 120 over 37, not a solution. When n equals 6, we will have again equal to 3, the fraction equals to 3, so again a valid solution. I'm not going to simplify the fraction, but we know that it's not going to be an integer. And actually, similar things will happen for n equals 8 and n equals 9. Both fractions, in fact, are between 1 and 2. And so therefore, we have checked all possible cases, and we can conclude that n is either 1, 2, 4, or 6. So this is the final answer. Please feel free to share ideas in the comments. Thank you for watching. See you next time.